Hey, thanks for stopping to pause for a moment of science. I want to talk to you today about global winds and something called the Coriolis effect. Now, when we talk about winds, they're pretty easy to figure out which type of wind we're talking about because there's usually a hint in the name. We tend to talk about global winds. Never mind. Hey guys, thanks for pausing for a moment of science. We're talking about winds today. Now we know that there are lots of different types of winds. You have your local winds, you have breezes, you have global winds, you have streams, all kinds of stuff. We're going to focus today on global winds, and I'm going to show you a really cool activity that you can do that shows Coriolis effect. Now, talking about global winds, well, you need a globe. We talk about winds blowing in a specific direction, west to east, east to west, south to north. We talk about northerly winds that bring that cold, bitter weather to us, and it blows from the north. So, direction is an important thing with winds. Now, global winds are winds that blow, well, around the entire globe. They continually move. They don't stop. They are constantly moving around the globe. Because of the Coriolis effect, global winds are able to do a little trick that the other winds can't do. Streams can't do it. Breezes can't do it. Any kind of local wind definitely can't do it. So basically, here's an example. So if global winds blew straight, all right, so if global winds blew straight, then only this small section of people would get their weather moved around. Everyone else would be stuck with the same weather, and that's problematic because if you're not getting wind to blow you clouds, you're not going to get rain, and if you don't get wind to blow your clouds away, well, then you're going to be stuck with flooding. So if global winds blew like the other winds and blew straight, only a small amount of people would get their weather moved. So I think this is, South America. So South America. I had to look, make sure. So that would be problematic. Lucky for us, the Coriolis effect bends global winds so that they actually hug the earth. And when they hug the earth, they can continue to go around and around and around. They are very high in the atmosphere, so they're not affected by skyscrapers. They're not affected by mountain ranges or anything like that, and they continually blow. But the hugging of the earth is what helps everyone, no matter where you live, well, no one lives here, but to get their weather moved around. So I'm going to show you how the Coriolis effect works. Something like that. All you need is, you can use cardstock. I used a file folder. You just need a thicker kind of paper, and I just cut a circle out of that. You need a pair of scissors to cut the circle out. You need a pencil, and you need a real pencil, not a mechanical pencil. It will not work with a mechanical pencil. You need a real number 2. And I have some food coloring. I made it dark. It's just water and blue food coloring, and I darkened it so that it would show up in a little dropper. So the first thing we're going to do is we need to put the earth on its axis so that the earth can spin. And how you do that is just take your good number 2, punch a hole right in the center of your earth, all right? Now, so you have the earth on its axis, but you don't have it spinning. So what you have to do is kind of loosen up that hole so that the earth will spin. And it has to spin. There's no such thing as too loose, all right? So don't be afraid to kind of pull and stretch and wiggle it out. You want it extremely loose because you want the earth to freely spin on its axis. It kind of reminds me of when you spin a basketball on your finger. You just kind of, spin it, give it a little go, and it moves freely. Now, when we're talking about the global winds, I tend to use the hint called TWE. Trade winds, westerlies, and easterlies. All right, and of course they have a little more appropriate names, but that just helps me remember. I say there are 1, 2, TWE different types of global winds, and so that's what we're going to represent with the drops of water. So take your dropper, get a little bit of food coloring, and you don't need a lot, but you're going to put TWE, get it, TWE drops on your earth. These will represent your 3 or TWE global winds. And you don't need very big drops. See that? Yeah, that's the stuff right there. Now, you're going to give it a spin, and you will see that because of the Coriolis effect, the wind, drop of water, wind will not shoot straight off the paper, earth, okay? It will actually curve and bend and hug and maintain blowing or circling the earth. Watch. See that? See how it all moved in a circle and stayed on? Give a little, oh, I made a mess right there. Don't do that. I'll show you again on the other side. So, again, take your disc, put your TWE winds on, give it a spin. Ooh, that's a good one. Ooh, 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 ooh. Look, look, look. Perfecto. Do you see how it bent? It didn't shoot straight off the page. It actually hugged and curved and continued its journey around the globe. Coriolis effect, baby. It's a thing.